Okay, so today we're in section 15.4, negative and zero exponents. We just have some special rules that we need to learn about negative and zero exponents. So rule number 1, any zero exponent. So all three of these terms have an exponent of 0. No matter if it's a number or a variable, what will the answer be? 1. It'll be 1. Okay? So the base is gone. And then the answer is just 1. All right, here's your next rule. Any negative exponent, we can write it as a fraction and flip the base. We flip it into the opposite side of the fraction. So that's what we see happening here in our little example underneath. We have 3 to the negative second power. Would you agree that as it's written initially, it's not in a fraction? Okay? But just like any whole number, I can write it over 1. And we practiced this yesterday with quotient of powers. Okay? So I just take that negative exponent, I write it over 1, and my rule says that I can flip it into the opposite side of the fraction to make it positive. So if it was in the numerator, I can flip it down into the denominator. We're going to do a lot of practice with that today. Okay? I can't evaluate a negative exponent. I have to make it positive first, then I can evaluate it. So we're going to practice. We're not even going to simplify yet. We're going to leave them as powers. We're just practicing writing negative exponents as positive. So in the first one, 3 to the negative third power, is that in a fraction right now? Is that in a fraction, guys? No, but any number I can put into a fraction by placing it over 1. All right, so if you see the number and it's not in a fraction, put it over 1. Now, my rule says I can put the term that has the negative exponent in the opposite side of the fraction. So right now, where is it? It's on top. So I can put it on the bottom. And now it becomes positive. So I just put it on the other side of the fraction. Okay. All right. I want you to slide over to c to the negative fourth power. What do you guys think about that one? Going by the same rule that we just talked about, what do you think we can do to make c to the negative fourth power positive? What do you guys think? Macy?
If it's over 1, you flip it, and then the exponent is positive.
1 over c to the fourth power. Is that what you guys were thinking? Just kind of nod so I know you're with me. Okay. 1 over c to the fourth. Okay. Now I want you to do 5 to the negative second on your own. All you're doing is making the negative exponent positive. Okay. That's all you're doing. We're just practicing that skill of flipping the term into the opposite side of the fraction. All right, Reese, what did you get?
1 over 5 to the second power.
Very good. 1 over 5 to the second power. Do you guys agree? Okay. All right, now, what do you guys notice about the last two in this example? What's different about these last two? Just tell them.
The negatives are on the
Okay, they're already in a fraction, right? And which side of the fraction are they in? They're in the denominator. So here's what you need to understand about the rule. The rule doesn't say put the term in the denominator. It says put the term in the opposite side of the fraction. So if it starts in the denominator, guess where it needs to go? To the numerator. That's how I make the negative exponent positive. So now this becomes x to the third power over 1. But do I even need to put it over 1? That's understood. I could just say x to the third power. All right, either answer. Okay, I want you to do the y. 1 over y to the negative 4th power. I want you to make that positive. Make that one positive. Okay. Mariana, what did you put? Y to the 4th power. Now, if I put it over 1, is that wrong? No, but it's not needed. So she just said y to the 4th power, and she's correct. All right. Any questions? Are you guys kind of getting the hang of it? Moving the term to the opposite side of the fraction. Okay. So now we're going to look at a product of multiple terms, okay, within one expression. So now I have x to the 3rd, y to the negative 2nd. I want you guys to go ahead and put that over 1. Okay, so if it's not in a fraction, it does help us visually, pay attention, it does help us visually see it in a fraction. All right, so now here's what I need you guys to remember. Each term is its own, it's independent of the other one. What do I mean by that? X to the 3rd power, does that have a negative exponent? No. Okay, but what about y? Y does. I can split them off. They're not connected together. All right, so if I want to write this expression with only positive exponents, I don't need to move the x. The x can stay right where it is. In fact, if you move it to the bottom, you're actually making the exponent negative if you do that. Okay, so we need to leave the x where it is. But the y needs to move to the bottom to make it positive. So this would be my answer. X to the 3rd over y to the 2nd. Now remember, if you flip the entire fraction, you're actually making the x negative. All right? Because my rule says moving the term to the opposite side of the fraction reverses the sign. So if it was positive, now it's going to be negative. Look at a, b, and c. A squared, b to the negative 3rd, c to the 4th. All right, I want you to place this expression over 1. And I want you to write this expression using only positive exponents. All right, see if you can do it. Which terms need to stay where they are? Which ones?
Positive.
Okay, the positive ones, a squared and c to the 4th, need to stay where they are. What's the only one that moves to the bottom? B to the negative 3rd power. Okay, all right, and positive 3rd. B to the negative 3rd moves to the bottom, making it positive. So B to the 3rd now. All right, so now let's see who can get this one. So now we see my terms are in the denominator, but remember my rule. All right, Kaylee, what would be my answer with only positive exponents? Very good. X to the 3rd power over y to the 5th power. So I only needed to move x to the negative 3rd up. Y could stay where it was. What do you guys notice about this last one?
It has whole numbers.
It has whole numbers. It has what we call coefficients. Can you reduce 5 over 10? Yes. You can reduce 5 over 10 to 1/2. How would you make x to the negative 2nd power positive? Where would it need to move? To the bottom, to the denominator. But that is independent. Independent means it's by itself. The 1/2 stays where it is. The 1/2 does not flip. Did the 5 have a negative exponent? Did the 10 have a negative exponent? No, my variables did. So my 1/2 stays frozen, okay? Just like it was. The only term I flip is my x. And then what happens with my y term? Where would I put my y term?
In the numerator?
In the numerator. Now, technically, do I even need the 1 there? I could just say y to the third power over 2x squared. All right, either answer would be acceptable because the 1 is understood. So we got some practice in with our negative exponents. Now we're actually going to solve these. Okay? Remember, number properties, in this case, exponent properties give us, what's that word that we love? They give us shortcuts. Shortcuts. Because here's the instructions. I have to evaluate this. Meaning, I can't have an exponent in my answer. These two down here, 6 to the 8th power. Can you imagine 6 times 6, 8 times, and then trying to simplify that? So why don't we see if we can use some of our number properties here to help us or give us a shortcut, make it easier because you have no calculator, okay, on this test. Maybe something can make it easier for us to solve. All right, so let's look at the first one. I cannot evaluate a negative power. So the first thing I need to do is make this power positive. How can I do that? How can I do that? What have we been...
Put it over 1.
Put it over 1. And?
1 over 3 to the 4th.
Okay, flip it. Now I'm ready to do my multiplication. Now this step you're not going to have to write in your work on your quiz and test. But I'm just showing you that it's the same thing that you've been doing. You're multiplying 3 times itself 4 times. Again, you don't have to write this step. But if you remember the other day, Julia's question, okay? 3 times itself 4 times gets to be kind of a big number. But remember, you can split this off. What's 3 times 3? 9. So then what's 9 times 9? 81. So guys, you can memorize this. 3 to the 4th power is 81. 3 to the 4th power is 81. So your answer is 1 over 81. You have to leave that power where you wrote it flipped to make it the positive exponent. All right? So 1 over 81. All right, now let's look at this next expression. Remember what we said. We can't evaluate a negative exponent, right? You guys remember that? But before you say, okay, I got to flip this. I need to put it over 1, put it in the denominator. Before you do that, do you guys see product of powers possibly here? Do your exponent properties first. Because maybe after you do product of powers, you'll end up with a positive exponent. You won't have to move anything. Maybe you'll end up with something else. So we have negative 8.5. Is that my common base? Okay. To the power of, I want you to write this step 2. Negative 4 plus 4. Let's simplify. Why don't we simplify them together and then evaluate the power? What's negative 4 plus 4?
0.
0. 0. So negative 8.5 to the power of 0 is 1. That's my answer. It's just 1. All right. Now, I want to hopefully help this make sense. If I had moved this to the denominator, guess what? I'm dividing a number by itself. So that's why my answer is 1. If I had moved that to the denominator. All right, but you don't have to worry about that. So, what do you think you guys would do first on this next one? Do you think you see the negative exponent and say, oh, I got to flip it? Or what could you do? Product of powers. Do I have the same base? Yes. So, 6 to the power of negative 8 plus 8. Do your product of powers first. What is negative 8 plus 8? 0. What's your answer?
1.
1 again. So instead of 6 times 6 times 6, a whole bunch of times and then trying to divide. Because, again, you have to have an answer. You can't write your answer with exponents. It'll be wrong. You have to evaluate it. And you're going to be asked to do that on your big ideas homework too. So use your exponent properties. Take your shortcuts. It makes it a lot easier. Okay. All right. Let's look at example 1B. Slide 2. Slide number 2. You know. All right. What do we see here? Lots of practice. So the last slide was product of powers. What do you see here? Quotient of powers. Quotient of powers. Okay, but now you got to be careful with quotient of powers. Okay, you got to be careful here because you are subtracting the numerator minus the denominator. So step 2 is important. 2 to the power of 6 minus 8. Remember, when you do this, you're bringing all of your powers into the numerator. What's 6 minus 8? Negative 2. Right? So 2 to the negative second power over 1. Do you see why we were putting them over 1 now? We were setting it up for the fractions here. So do you guys know what to do next? What would you do next? I want your minds spinning. Lucas, what do I do now? Yeah, flip it. Flip it down into the denominator. Make the exponent positive. What is 2 squared now? 1 over 4. So I have to evaluate it all the way until my exponents are no more. Look at this next one. I just want you guys to look at it, kind of study it for a minute. Before we say anything else, I just want you to look at this next expression. I want you to think what you would do first. What would you do first? All right, just take a minute to look at it. Anybody want to tell me what would you do first? One person. I know there's more. Julia, are you working it out?
I'm trying to solve 5 and 7 problem first. And then because when you multiply the
But we're not doing 5 times 5 7 times, are we?
oh.
No. What do we want to do, Sebastian?
You could just do product of powers, I think.
Okay, you said product of powers because I'm multiplying these fractions together. Okay? So that means I can apply product of powers in my denominators. I can multiply. Remember, when I multiply fractions, I'm multiplying straight across, right? So 1 over 5 to the power of 7 plus negative 4. So I can add my exponents together. What's 7 plus negative 4? Positive 3. So don't just automatically think, oh, I got to move my negative exponent to the top, because maybe after you do product of powers, you actually don't have a negative exponent. 1 over 5 to the third power. So what is 5 times 5 times 5? 125. 1 over 125. That's my answer. All right, how are we doing so far? You guys doing okay? All right, so look at this last one now. Look at this last one. What do you guys think? So there's one catch here. All right, actually, I want you to do this problem. I just want you to do it completely. I'm going to come around and check. Okay, so I have negative 3 to the power of 5 minus 6. You guys did really well in that part because I need to subtract my exponents. So then I get negative 3 to the power of negative 1. 5 minus 6 is negative 1. So what do I need to do? Where does that term need to go? Down into the bottom of the fraction. 1 over negative 3 to the first power. This is not evaluated. It's not evaluated. If I'm evaluating the power, I can't have parentheses. If I have parentheses, that means it's not been evaluated. So my answer is negative 1/3. Now Lucas had 1 over negative 3. That's perfect. That's fine. You cannot have parentheses or an exponent, even if it's an exponent of 1. All right. Okay, so got a little picky there, but that's how I would write my answer. All right. Now for example 2. Now we have a product of multiple terms. Remember, I'm going to have these negative exponents. I'm going to have exponents of 0. Negative 5x to the power of 0. Which term has a 0 exponent? X. Negative 5 has its own exponent. If nothing's there, what is it? It's a 1. So here's what I need you to understand. This is the same thing as negative 5 times x to the power of 0. Right? A number times a variable. This is a product. Negative 5 does not have a 0 exponent. Anything raised to the power of 0 is going to be what? 1. So this is negative 5 times 1. What's negative 5 times 1? Negative 5. Do you guys understand where x went? Because there's no x in your answer. X to the power of 0. Anything raised to the power of 0 becomes 1. How you guys feel about that? Is your brain hurting yet?
No.
Not too bad?
At first I was like, I need a product of power since I have the same base and that.
Yep, not the same base. You can't do product powers. All right, look at this next one. Got a 9 out here. Does 9 have a negative exponent? This is where we see the mistakes. When you're trying to decide what to flip, what not to flip. Okay, does 9 have a negative base? No. 9 is going to stay where it is. You can do quotient of powers here. Now, I need to be careful on this too. This is not the only way to do this simplification, to simplify it. All right, but I'm going to stick with quotient of powers because you guys are getting comfortable with quotient of powers. So 9 stays on top. Now I'm going to do quotient of powers with my y's. So now I have 9y to the power of negative 3. I have to minus it, and I minus 5. So what's left in my denominator? Do I have any y's left in the denominator? No. I subtracted them all up into the numerator.
Why would it switch if the y to the power is 5? Something's positive.
You're doing quotient of powers.
Oh.
You're doing quotient. So you're just subtracting them, and then we'll deal with the negative. What's negative 3 minus 5? Negative 8. So 9y to the negative 8th power. Can this be my final answer if I want no negative exponents? No. So I need to put this over 1 still. Keep it over 1. Now here's the $1 million question. What flips?
Just the
Does
y.
Does the 9 have a negative exponent? No, it does not. It has its own understood exponent of 1 if there's nothing there. The 9 stays on top. 9 over y to the 8th power. All right, I'm going to back up and I'm going to show you another way you could have done this. Some of my pre-algebra kids really preferred this, and I'm fine with this. You also could take y to the negative 3rd power and put it in the denominator. Was anybody thinking that?
Yeah, that's why I was.
Were you thinking that? Okay, you can do that. So, again, if I want to switch the sign, you cannot evaluate until the, well, anyway, it's fine with a variable. So if I move it down into the denominator, would you agree it becomes positive? All right. Now when I multiply these, I'm going to get y to the 8th in the bottom. So you definitely can do it that way. I just tend to just do quotient of powers because it stays consistent. All right, I want you guys to do the last one. Have y'all done it yet? Okay, go ahead and do the last one. What did you get when you simplified your n's? N to the what?
Into the
Negative 3rd power over 6. All right, now here's the test. Here's the test. What is your final answer? Does anybody want to tell me what they got? Lucas?
6 over n to the 3rd power.
Okay, that's the most common incorrect answer. Okay, so don't feel bad because you're not alone for sure. Sebastian, what'd you get?
I put 1 over 6.
Okay, does 6 have a negative exponent?
No.
It has to stay where it is. So if you move it to the top, you're not flipping the entire fraction. You only flip the terms that have negative exponents. 6 has to stay where it is. But the n moves down into the bottom. You say, okay, then what's left? The understood 1 that's in front of the n. So it's just 1 over 6n to the 3rd. Did anybody get that? All right, very common to flip the whole fraction. But remember, 6 does not flip because it did not have a negative exponent. All right? Okay, we're winding down now. I'm going to leave you guys on your own for these 3. I'm going to give you guys about 3 questions in 3 minutes. I think we can do that.
1 minute per question.
1 minute per question, which, I mean, the first one shouldn't even take a minute. Okay, so go ahead and work together. I want you guys to compare your answers with a neighbor. Okay, first one. Did you put it over 1 so you can visually see it in a fraction? Does the 8 flip? Does the 8 have a negative exponent? No, it stays where it is. 8 over x squared. All right, thumbs up if you got it. Did you guys get it? All right. Now your b. What did you do with this first term?
Made it a 1.
Make it a 1. So 1b to the negative 10th power. Can put it over 1. What's your answer? What'd you guys get?
1. 1 b to
1 over b
1 over. Did you move b to the 10th down into the denominator? Okay. So because remember guys, this was all in the top part of the fraction. You can't have a negative exponent in the numerator. Okay, 1 over b to the 10th. Last one. So I have my z's. So I have z to the power of 6 minus 9 over 15. All right, so let's see if history is going to repeat itself from the last slide. What is 6 minus 9? Z to the power of negative 3 over 15. Lucas, what'd you get for your answer?
Oh,
All right, remember what we did on the last one?
15 over.
You had your chance at redemption.
That's why she said, I wonder if history's going to repeat itself. And then you
All right. Macy, help him out.
1 over 15 z to the third power.
All right. 15 does not move. Did 15 have a negative exponent? No. Keep it where it is. Every term is its own individual term. If it doesn't have a negative exponent, leave it alone. Don't bother it. Okay? All right. Double negatives. What do I mean by that? Quotient of powers. So here, this is why, all right, the method that I've taught you in the previous examples is not the only method to simplify negative exponents. However, it is the method that works the best when you end up with a double negative. So that's why I've been doing quotient of powers. All right, so my rule says I subtract the numerator minus the denominator. Quotient of powers. So now, and again, this is why I'm having you write step 2. Now I have x to the third power minus, what am I subtracting? Minus a negative 4. It becomes a double negative. Now remember, I still brought all my powers of 4 up, so now I have a 1 in my denominator. But the double negative changes to a what? Positive. So now my answer is x to the 7th power. X to the 7th power. Okay? So quotient of powers, here's where I see, okay, ding, ding, I might have a double negative here. If I'm doing quotient of powers and my denominator power is negative, when I subtract it, so negative 3 minus, what am I minusing here for A? I'm minusing a negative 6. So what does the double negative become? A positive. And what's negative 3 plus 6?
3.
A to the third power over 1, or you could just say A. Because you subtracted all your powers up into the top. Huh? A to the third power. That's it. That's your answer. A to the third power. All right. So you might have one, like maybe 1 or 2. You're not going to have a ton of double negatives, but you do need to watch out for that. All right. Here's your challenge. How can you write the number 1? Your answer has to be 1. But your base has to be 5, and your base has to be 10.
Oh, that's easy.
It's so easy.
What? What's so easy about it?
You just add the 0.
Okay, so how could I make a base of 5 become a 1? Write it to the power of 0. Well, it's probably because of how I wrote it, too. If I had just, I don't know. You probably still would have got it. I know, right? Okay, guys, that's it for today.